this question, we are informed that Boris has a bag that only contains red sweets and green sweets. Boris can takes at random 2 sweets from the bag, so this is without replacement. The probability that Boris takes exactly one red sweet from the bag is 12 over 35. So originally there were three red sweets in the bag, so the number of red sweets, three. Work out how many green sweets there were originally in the bag. Okay, so what you're going to do here, the first step is we don't know how many green sweets were in the bag, so we'll introduce algebra and let the number of green sweets be x. So let the number of green sweets be x, because we don't know how many there were. So the total number of sweets in terms of x, so total number of sweets in the beginning will be x plus 3, because these guys here are x, these guys here are 3, so x plus 3. All right, so what we want to do here is we know that 2 sweets were taken from the bag without replacement. We want to find expression in terms of x for these probabilities, because we know that the probability that Boris takes exactly one red sweet from the bag is 12 over 35. So if you let that to be red and then green for the first event, because you can pick either red or a green sweets for the first event, and then for the second event you can also pick either red or green if the first one was red, or we can also pick a red or green if the first one was green. Now for the first event, the probability of picking red is 3 over the total number of sweets, which is x plus 3. And the probability of picking a green will be x over x plus 3. So the probability of picking the second one being red, uh, the probability of the second one being red, given that the first one was red, remember this is without replacement, means that this will be 2 because the number of reds has reduced by 1. The total number of sweets will also reduce by 1, so that will be x plus 2. And here, if the first one was red, the number of greens is still the same, so x, but the total number of sweets would have reduced, so x plus 2. The same thing here, if the first one was green, the number of greens have reduced by 1, will reduce by 1, and the total will reduce by 1 as well, so x plus 2. But here, because the number of reds are still the same because the first one is green, that will be 3 over x plus 2. Okay, so what you're interested in is exactly one red sweet. So, I mean, if you look at this branch here, that's 2 red sweets, that's 2 green sweets. No, we don't want that. So exactly one will be either this branch or that branch. So this is probability red and green, yeah, which is exactly one red. Here we have exactly one. And the probability for that will be the product of these branches, which is 3 over x plus 3 multiplied by x over x plus 2, okay, which will give you 3x over x plus 2, x multiplied by 3, x plus 3, sorry. Yeah, so that's the product of these two. Now here we have probability of green and red, which is, here again we just have one red. So here that will be x over x plus 3. So basically the product of these two branches multiplied by 3 over x plus 2, which will give you 3x over, again, this multiplied by that. It doesn't matter the order. When you multiply the two expressions or two numbers, the order does not matter. But we know that all this add to 12 over 35. So these two probabilities add to 12 over 35. So basically we can go ahead and say, all right, so we can say 3x over x plus 2 multiplied by x plus 3. And now, when you have the word or, you add. Or implies you add. Yeah? So we have either this or that. So either this or that, which is 3x over x plus 2 multiplied by x plus 3. And this 2, yeah, because here the probability that Boris takes exactly 100 sheet from the bag is 12 over 35. It means that this probability is added to 12 over 35. And then from here, it's just the algebraic process of solving it. So let me just bring all this to one side here. So this expression can be written as this. So we have 3x plus 3x, because if the denominators are the same, if you notice here, yeah, we have same denominators, we can add the numerators. So over x plus 2 multiplied by x plus 3. All right, again, I just need to draw a smaller line here. And this is equal to 12 over 35. And then what I'm going to do next is just to simplify the numerator here. Now, again, you know that you can FOIL this as well. Yeah, you can FOIL the denominator. So anyway, for the numerator, we'll end up with 6x. For the denominator, if you FOIL, end up with x squared plus 2x plus 3x plus 6. And this should be equal to 12 over 35. This simplifies to so this will be equal to 6x over x squared plus 5x plus 6. This will be equal to 12 over 35. And then we can cross multiply here. So 6x multiplied by 35 will be equal to 12 multiplied by x squared plus 5x plus 6. Now this will be equal to so 6 multiplied by 35, that's 220x, and that will be equal to 12x squared plus 60x plus 72. Bring everything to one side, you'll end up with 12x squared if you bring that, so 60 minus 210, what's 150x plus 172, no, plus 72 is equals to 0. Now all these are multiples of 6, so divide by 6 on each side. So you'll end up with x squared minus 25. Actually, this is 2x squared. My apologies. 2x squared minus 25x plus 12 is equals to 0. Now we need to solve that quadratic equation, so that's why I'm going to move on to. So here we have 2x squared minus 25x plus 12 is equals to 0. Now to solve that, we can just use the quadratic formula. So x is equal to negative b plus minus square root b squared minus 4ac over 2a. So that will be negative 25 plus minus square root negative 25 squared minus 4a, which is 2c12 over 2 multiplied by 2. Okay, this negative and negative, that will just be 25 plus minus. You can plug whatever is under the square root in a calculator, so that will be 529 over 4. So this is either means we have 25. Now this, the square root of 529 is 23, so that will be 25 plus minus 23 over 4. So either this means that x is either equal to 25 plus 23 over 4, or x is equals to 25 minus 23 over 4. Now this will either be equal to 12, or x will be equal to a half. Now obviously what you're trying to solve for here is the number of sweets. You know, x represents the number of green sweets. So the number of green sweets can never be a half, so definitely that's out. So that implies that the correct solution is 12. So there were 12 sweets originally.